All right. I want to specially welcome everyone to class. Okay, so this is the day three of this professional training, industrial machinery maintenance. Yes, it's so good, it feels good and great to be part of this final day for this training. So we are going to be bringing the training to a conclusive end in today's class. All right, so I want to say a very big welcome to everyone, and thank you all for being a part of this learning journey from the onset. Uh, really appreciate when I see people who are so zealous of knowledge, who actually want to get better in their field of profession. So I want to congratulate you all for being a part of this class. Yes. Many people might not know the importance of benefit that this or such trainings will give to them, not until they have need for it. All right. So I want to say welcome to you all once again. Thank you all for being a part of this training. Yes, like we all know, this training is brought to you courtesy CUC Concepts Training Company Limited. Yes, we are a professional training firm. Yes, as we move on, even after the training, yes, we are still going to connect better. We'd love to see more of you. We'd love to see more connections from you, training, perhaps training deals from you as we progress, to in order for us to bond or have a better relationship with one another. All right. So I say welcome to everyone for joining the class. Yes. Um, okay, virtually everyone I'm seeing in classroom with me have has been a part of this class since onset. I don't think I've seen any new faces or any new person just joining us. All right. Okay, that's great. Okay, so yes, we are going to be picking up from where we stopped yesterday. And I also want to appreciate our resource person, excuse me. I also appreciate our resource person, Mr. James Fanny, for being so instrumental in the delivery of this course. Yes, it has been a very great experience working with him. Yes, and I want to affirm that yes, even those who are a part of who have been a part of his class can also attest to the fact that yes, his class is always very interesting. Yes, he always meets expectation when it comes to delivery of his classes. So we say a very big thank you to you, Mr. James Fanny. All right, so yes, he's here already with us. So in a brief moment from now, and the next voice you'll be hearing will be that of our resource person, Mr. James. So a whole lot has been discussed on industrial machinery maintenance through the two classes that we've had so far. Yes, so in today's class, let's see what we can do on I think pneumatic and hydraulic systems, automation and control systems. And I always emphasize that yes, even the electrical system as well. I think we are going to touch on that in today's class. I always emphasize that yes, what we are really dealing with is the maintenance aspect of all these systems, all these machines. We are not looking at the working principle or integrity of all these machines. Yes, if you want to do that, that's a separate training for that. For the maintenance aspect, which is very core and important to any industry, is what we are going to be looking at. What we are looking at rather, as far as this training is concerned. Hence the name industrial machinery maintenance. All right. Okay. So on that note, let's but before we do that, let me just take one person to give us how's the class been so far. Oyewa, your media praise. Mr. Oyewa, if you can hear me, I would love you to unmute your mic. How's the class been so far? Oyewa, your media praise. Yes, if you can hear me, can you unmute? All right, Shitu Samuel, if you can hear me, please unmute your mic. We'd love to hear from you. How's the training been so far? Shitu Samuel. All right, I guess those are busy. Precious, I can see Precious. Okay, is that Shitu Samuel? Okay, yes, Mr. Shitu, please Good. Thanks for being a part of the class. How's the training been so far? We'd love to hear your experience.
Wow, it has been insightful. So I
All right.
think I learned a new thing. Though I've worked as a field maintenance engineer before.
All right. Okay. Yes. We appreciate that a whole lot coming from you. So, like we always say, please let us try as much as possible. If at some point we've not been able to follow up on the classes, let's try to rewatch the recorded classes. Yes, we try as much as possible to ensure that the links to the recorded classes is being dropped on the WhatsApp platform. So please let's do that in order for us to um, not to be lost, as to what has been taught in this training so far. So the classes are still going to be there. They are going to be accessible. So anytime you have free time on your hands, try as much as possible to rewatch them. All right. Okay. So thank you very much, Mr. Shitu Samo. All right. So let's go straight to today's class. So at the end of today's class, there is going to be um, assessment. We are going to be dropping the assessment link to this training so far. So everything that has been covered in the course of this training, you are going to find them in the assessment. So you want to rewatch the classes before you attempt, the assessment. That's if you have not followed through with, or you have missed out on any of the classes. So please rewatch the recorded classes. Then you proceed to attempting the assessment. So you are going to be having 5 assessments um, based on every categories that has been taught. Assessment on industrial mechanical machinery, assessment on industrial electrical machinery, assessment on industrial pneumatic and hydraulic machinery maintenance, assessment on industrial control system and automation machinery maintenance, and assessment on industrial maintenance safety. So these are the areas, the 5 areas that you are going to be having your assessments on, and these are the areas that um, the certifications also cover. So regarding the certification, depending on which area is um is a relative or related to your field of profession, then you can go for the certificates. You necessarily don't need to take all the 5 certificates, but it is also good if you have these 5 certifications as well. So if it's your versed or have a profound foundation in the aspect of mechanical, then you can go for both the mechanical and pneumatic and hydraulic, or you can go for the mechanical alone. If you have a foundation in mechanical, both mechanical and electrical, then you can go for the electrical and mechanical related control system and automation as well. So industrial machinery maintenance, industrial maintenance safety is peculiar to all. So it's good you have the certification in that aspect as well. Okay, so further information regarding that, we are going to be um, emphasizing more on it, perhaps maybe at the end of the class. All right. So those are the brief informations that I'll be giving to you before we dive into today's class. Permit me to switch devices. All right. So please, if you can hear me, just give me a thumbs up if you can hear my voice. All right. Thank you very much. I'll do, Joshua. Thank you so much. Thank you. All right. So at the end of the class, any other information that we have is going to be passed across to us. All right. So like I did mention, we have a resource person here already with us, and that's James Fanny. So at the end of today's class, yeah, I expect that we are going to be having questions. So questions that you've not been able to ask by the end of the class. So let's try as much as possible to note them down, and we'll have all the time to be able to deal with, attend to every questions that you might have in today's class. All right. So yes, our resource person, Mr. James Fanny, is going to be taking us through today's class. Okay, so please let's give him our undivided attention. So at some point, he might call on us to respond to
a question or the other. So please, let's do well to what's it called? To respond. Yes. All right. So the next voice will be in with that of our resource person.
So I want to start with hydraulic and pneumatic system. So I want to start with hydraulic and pneumatic system. We have really discussed, almost the nook and cranny of things that we need to know as basics for machinery maintenance. We have also discussed those ones that affect the mechanical, like in our second class, we discussed a lot about that. I want us to start from hydraulic, and then we talk about, some of the mechanical also, that's mechanical machinery maintenance, and then we dive into some part of the electrical, so that it will be an all-rounder kind of training, because the plan is to touch all these areas for different kind of people that we have from different fields who actually registered for this training. So when we talk about hydraulic and pneumatic systems, of course, many of us might have, in one way or the other, we have actually either interacted with some of these machines, operate them, or we have them, in our industrial environments. So they are actually industrial machinery and equipment, and we have hydraulic system that has to do with what usage of oil, okay, to power some of this machinery, and we have some that are using what air as the power, which is actually what pneumatic. So let's briefly look at the components of hydraulic system. In hydraulic system, you can have motors, we have the cylinder, okay, because like I told you, it's making use of oil. So you have the cylinder, you have the valves. The valves is like an open gate. It's used to actually regulate the pressure. Okay, so you can use valves to regulate the pressure. We have the filters. I explained some of these in second class, talking about your oil shouldn't be contaminated. So we have filters there that can actually filter some of the contamination. And in most cases, when you're performing your maintenance, you have to check on the filters also. So if there are some clogging already happening there, some, just like something refrain or holding back debt for over time. So it's like your gutter. If you fail to actually remove those blockages in your gutter or your drainage, definitely you will see that water will not be able to flow. So the same thing with your filters. So if you have contaminations or some dirt that are already accumulated on it, sometimes you have to bring it out and just clean it, and sometimes you have to change the filter completely, depending on the system that you are dealing with. So pardon me, I'm using a different device. My device is so. We also have reservoirs. This reservoir is to store the oil that you are using. Okay, the oil that you're actually using, you use reservoir to actually store it. I hope we can still see my screen. Can we still see my screen?
Your screen is showing, it's not showing the material.
Okay.
Perhaps you should stop presenting and represent, I guess.
Okay. I really want to share the material, even though I can actually move it without sharing the material. I want you to inform me. Okay. Okay, we are good now. Thank you so much. I think my device is back. Thank you so much. Yes. So you can see it now, right? Can we see my screen
Yes,
now?
you can go ahead, sir. You're maturing go.
Yes, yes. Yes, you can see it.
Thank you so much. So we have the, thank you so much. So we have the hydraulic components, we have pumps, we have motors, we have cylinders, we have valves, we have filters, we have reservoirs, okay, for the storage of this oil. And what is the work principle, the principles that hydraulic system actually work on? It works on Pascal's law. How many of us still remember Pascal's law? How many of us in the house, the engineering, the science-oriented people among us, or in fact, all of us, I expect us to actually be science-oriented. How many of us still remember Pascal's law? How many of us? Anybody? There's nobody in the house that remember Pascal's law.
It's been a long time.
It's been a long time.
I think this is very just not possible.
Okay. So Pascal's law is actually the law that is applicable to when you're talking about it governs the transmission of power, governs the transmission of pressure within that particular container. So, and then when you are talking about the formula is what you actually brought up. But in my own training, it's not the formula I actually want to treat. Okay? It's not the formula I want to treat. I want to actually treat the application. So, as you have rightly said, the pressure itself is equal to force over area. That's the pressure. Okay? But Pascal's law and the application of, how the pressure transmission is in an enclosed container. Don't forget that we are talking about hydraulic system. And in hydraulic system, you have the oil actually in an enclosed system. So the way the pressure is actually distributed within that container is what is governed by Pascal's law. I don't want us to be going into those theory, but just the application. So the principle also relies on hydraulic pressure, the flow rate. So the flow rate, like I discussed about valve. Valve can actually be used to actually govern the flow rate, okay, to control the flow of this oil that we use in hydraulic system. So what is the application of hydraulic system? Heavy machinery. Okay, heavy machinery, I mentioned it in the second class. They make use of hydraulic. Construction equipment, they make use of hydraulic. We have manufacturing machinery, they make use of hydraulic. Now, the aspect that concerns us, because as you can see, I'm not really focusing on all that, is the maintenance of hydraulic system. Now, what are the maintenance which we are actually learning in this course? These are the places where I need to actually lay emphasis. So there should be regular check, on the fluid levels. So you have to conduct a regular check on the fluid level. So always check, and also check the oil condition. It is very important. Whenever you are also performing your maintenance, you should know when to change the filter. In most cases, oil filter, when you are performing your preventive maintenance, okay, it is good to actually replace the oil filters, and also use the recommended oil. The recommended oil should actually be made use of. So you should use the recommended oil. In our second class, I made mention of sometimes you have to go through the manufacturer's prescriptions. There are some manufacturers of equipment that they also produce the oil that equipment can actually use. So if there is a particular oil that it has to use, try not to think that you can outsmart the manufacturer. Use the oil that is prescribed for the hydraulic system. One of the issues that you may have with hydraulic system is leakage. Okay, leakages. When you see that the pressure is not coming, so if you go and check, there might be what leakage somewhere, because like we explained that what the oil is actually the one producing the pressure, is the pressure of that oil that we actually want transmitting into the power that the what equipment is using. So we have to inspect for leaks, okay, if there are leakages and all that. Whenever there is a problem with hydraulic system and you have to troubleshoot, most of the issues that you can have is either you have low pressure, or you have high pressure, or you have leaks, okay, or you have clogged filters. I've explained that. So it's just like what packing dirt, okay, dirty, or things that could contaminate what the oil, dust, and all that. They will clog on the what? On the filters. And what is the use of filters? Filters means that what the oil, that's where the oil is actually what passing through. We put the filter there so that what oil will only pure and clean oil will be able to flow into the system, and anything that has to do with what dirt or anything that is not clean or contamination that is in the oil can actually what be retracted by the filter. So you can imagine if the filter is doing the job over and over again, and for a long time, you just leave the filter there and it's not really being replaced. Or in some system where you have to clean, but for the oil, it's good that when you are performing the maintenance, just change it because of the what clogging that may actually what happen there. So that's briefly about what hydraulic. Pneumatic system. In pneumatic system, we also have components. We have compressors, okay. We have air tanks. We have valves. Also, I've explained the valve is also doing the same work that we explained it to be doing when I was discussing about what hydraulic system. We have cylinders, just as we have in hydraulic also, okay? We have motors, that's the drive itself, and then we have filters. So we also have air filters. Yeah, there are air filters, because there's also some dust, okay, that that may actually will contaminate, the air that we are making use of. So we need to actually filter it. So we also make use of filter. The principles. Those also work on the principle of what Boyle's law. Do you remember Boyle's law?
Yes, sir.
Okay, can you help with that?
Boyle's law says that in a system, provided that temperature and other physical properties remain constant, the pressure provided is directly
this mass of gas is inversely proportional to its what pressure. We normally have a V1 equal to V2. So meaning that what, when we look at that, the inverse proportionality actually shows that the higher the pressure, the lower the what volume, or the higher the volume, the lower the what pressure. So that's just the principle it actually work on. Okay, it is very important. See, that's actually the problem with our education system. It's not anybody's fault, okay, that we struggle with it. But trust me, it will make more sense when you work with most of this equipment. You will appreciate the principle that we learned back then in school, all this theory. They're actually meant for the application, and you can use them to troubleshoot. So when you know the principle that is working with, you can easily troubleshoot. Like when I was mentioning about what Pascal's, okay, the Pascal's law. You understand Pascal's law, okay? Then you will know when there is what problem with what pressure within an enclosed fluid. Okay, when there is problem with what pressure, okay, you'll be able to actually what troubleshoot. I don't want us to turn it to theory class, stating Boyle's law and proving and all that. So I could have actually brought it out for us to discuss. But the principle is also based on air pressure, the flow rates, like I explained about valve. Applications. Manufacturing machinery make use of pneumatic. We have material handling equipment making use of pneumatic, and we have pneumatic tools. These are systems that are making use of air as a source of power. Okay. What is the regular maintenance that you do on pneumatic system? Regularly check air pressure and flow rates. It's very important. Replace filters and lubricants, when needed. So just as I mentioned when I was talking about the hydraulic water system, you need to also change or replace the filter of the air filter, okay, when necessary. Inspect for leaks. One of the greatest issues that you can also have is the leak, okay? Just like you are trying to gauge your tire of your car, you gauge it now before you move 3 hours or 4 hours. You see that the tire has gone down. So there must be leaking somewhere. Okay, you might not actually be able to diagnose, or you are not really, it's not really a loud one like that, but the tire is actually leaking somewhere. So in the pneumatic system also, you watch out for leakages. Okay. Inspect for leaks. How do you carry out troubleshooting? Low air pressure, just as we have in hydraulic also, there can be low pressure, there can be high pressure. Okay, within the system, within the hydraulic system, or within the pneumatic system, there can be leaks. These are the major issues that you have with the system. So when you want to troubleshoot a pneumatic system, what you are looking for in your mind is that with the way the equipment is behaving, is this due to high pressure? Troubleshoot with the mindset that no, it could be low pressure. We troubleshoot with the mindset that it could be that it's leaking somewhere, and you troubleshoot with the mindset that the filter could have clogged somewhere, that might be clogging on the filter. So if you follow this troubleshooting, I'm assuring you will still remove the material. You see how we actually put everything in good things there. So if you have this form, you have this direction about the troubleshooting, it will not be difficult for you to resolve any issues relating to pneumatic or hydraulic. So let's bring the common issues out together now. The leaks that I explained in the hydraulic, when you're talking about leaks, we are talking about the fluid leaks. When the fluid that you make use of, the oil, when it's actually leaking somewhere. So that would actually be the problem. So you look for leaks in the oil. When it comes to pneumatic, you look for air leaks. When we talk about the clogged filters, the fluid filters could actually clog all the air filters, as I've explained that. You should also check for worn or damaged components. Okay, maybe the cylinders, hydraulic cylinders, or the pneumatic cylinders. They could also be worn out, or they could be damaged. Your valves should be inspected. There will also be problem in the use of incorrect fluid. I've explained that, and I cannot really, I can't say that, more than enough. You have to use, the prescribed fluid, for the system. It is very important. The air pressure should be monitored also. The hydraulic pressure should be hydraulic fluid pressure should be monitored, and the air pressure should also be monitored. Many people don't know that. People just take their car to all these vulcanizers, they say they should actually gauge for them. And when they gauge your car, you just they could, the pressure of your car tire can be too much, and that would be dangerous for you to drive with. And that is why if you see a very good one among others, vulcanizer, they will show you, they will bring out the pressure gauge. In fact, you should ask for it. There are many people that even have it in their car. It is not too much. It does not really cost that much for you to actually have. So before you actually conclude that, the pressure of this tire has gone down, you need to actually plug it in and check the pressure. And you work with the prescribed pressure of that tire. The manufacturer of your car, or the manufacturer of that tire, if you need to research where the pressure is actually so you should need to actually pump your tire with the accurate needed pressure. Not high pressure, not low pressure. Because both of them are actually dangerous. So what many people care for is that, there is low pressure in their tire, and they want to pump it. Many people don't really mind or think about what about the high pressure? What are the tools and equipment that you may need in the maintenance of this? Your hydraulic pressure testers, okay? Just like I make mention of, you need to measure the pressure. So there are pressure water testers, okay, that will show you that, oh, this is the pressure that is in there. And you'll be able to know if that is the prescribed what pressure for the system that you're working on, the machinery, the machine that you're working with. Pneumatic pressure testers, okay, for measuring what air pressure also, like the one I mentioned about tire. Yes, they are there for you to use so that you'll be sure that you're not working with what, or you're not driving with what. In the case of car, I'm using it as an example, with too much of pressure or low pressure. Okay, we use meters, we use multimeters in the system. The safety remains the same, like we have mentioned what in our second class. The safety are always what almost the same. Your PPE, your logout taggers before you perform maintenance on it. It is happening in a confined space. Okay, confined space entry happens to be, if there's a restriction to the entrance of where you want to go and work. Let's say, just one way in. There are some places like that, one way in, one way out. That's confined space, and only one person can go in and bodily enter the place, and you can use only limited time. Maybe if there are anybody here that has worked in a confined space here, you can share your experience at the end of the class. So only one person will be able to actually go in, go out. In fact, in some confined space work, there are people that when they are going in like that, they will have to tie, something like chain to their leg. Something like a rope or chain like that will be around their ankle, such that somebody will be outside that will intermittently be checking on them by dragging the chain. So if everything is all right, you kick your leg. The person that is inside, that is walking inside, we have to kick his leg, drag the chain back, which actually shows that everything is all right. If not, if they drag the chain and there's no response, they have to drag him out, because it's a confined space. Sometimes some people go in with additional oxygen to breathe in. Sometimes they have to do air tests to there to know if they are performing welding work there, if there could be fire outbreak or anything like that. So when you are working, the pneumatic system that you want to go and maintain is in the confined space. That's what we are talking about. You have to take an extraordinarily, authorization when it comes to safety. Sometimes even the first aiders will be on guard, and everybody will be there because anything could actually go wrong. So say following the procedures for entering confined spaces when working with hydraulic and pneumatic system. It is very important. So those are the safety precautions that you actually have to take when working with hydraulic system and pneumatic system. So what are the best practices recommended for this? Follow the manufacturer's instructions. I've said that over and over again, so I don't need to emphasize on that. Follow the manufacturer's instruction. Okay? Use proper tools to perform your maintenance. Don't try to force tools. Don't try to force tools. Don't say you want to improvise and a bolt that is supposed to actually moves with 13 spanner. Sometimes you see most of those things actually happen. You are using a wrong spanner, or you are using a wrong tool on a particular bolt, on a particular joint for a long time. So what will you see? You will see that it will run out. Even when you bring the correct tool, you won't be able to actually open it again. It's sometimes it's human fault. Most of these things are human faults, because you are using tool to actually perform your maintenance or to do your work or installation. So use proper tools, okay? The personnel that will actually carry out the maintenance must be a trained personnel, somebody that is trained to do it. We shouldn't just push people to go and say, oh, you can do it. It's a very simple thing, okay? Or something that you just go and watch the video and then you want to go and try it. No, you have to be trained on it. It's very important. The procedures that should be followed should be documented so that it will help every personnel that wants to work on it. Okay, what is the procedures? Do you have to open this place before you move this place? Do you have to close that place before you open this place? Those are the procedures. It should be documented. It shouldn't be something that you believe that So the person performing the maintenance should actually know. No, there should be documentation about it. Like in our last class, my friend here that shared his experience about how they take, Lotto at their place of work. So you can see that is what proper documentation. Everybody already have a Lotto tag. They can take what group Lotto to them to actually go and perform what maintenance. Like more than one department performing maintenance on a particular system at the same time. So these things are documented. So anything about maintenance or any machinery in a company should be documented. If you are working in a company where all of you just know the maintenance of a particular machine by heart, just know that it's the wrong practice. It has to be documented. What you need to do when you are maintaining a particular system or a particular machinery, you have to have documented procedure to follow. Because that's all what could actually nail you, that can crucify you, or at the same time free you whenever you are performing your maintenance. If you actually do all these things, should you check the oil level? Must you change the oil? Must you change the filter? Must you do this and that? All those things should be documented. It shouldn't be assumed that you know. And we have some regulations and standards here. I just put it there for you to actually see that there are standards, there are regulations that actually manage all these things across factory. So I've talked about hydraulic system troubleshooting. Opeyemi, please. Kindly mute. Thank you. So we talked about the pressure, okay? Pneumatic system troubleshooting, I've discussed it. Everything I explained, I try to, kind of elaborate them the more. That's what you are seeing that I'm actually sliding. So just to elaborate more on it so that you can have my explanation documented. So, all right. So let's talk about electrical system maintenance. Electrical system maintenance. So what do we do in the course of maintaining electrical system? The regular maintenance, which is the new one, the scheduled one, the popular one that I've been mentioning that is very important, that's the preventive maintenance. So the preventive maintenance of electrical system is that you need to do regular inspections. And when we are talking about regular inspections, you need to check the system for wears, for damages, or overheating. It is very with the electrical system. Overheating is very common with electrical machinery. Okay, electrical machinery most of them suffer a lot from overheating. So you need to do these regular inspections on them, and you need to inspect electrical connections also. Okay, check your wiring and check the components. It's very important. Sometimes you may have a loose connection. Sometimes you may have a dangling connection. Sometimes you can have a burnt connection already. So you need to actually check, because if there's overheating, some parts when you have actually connected or joined together might actually be suffering from burnt. So you need to check this occasionally. When you are performing maintenance on electrical machinery, you need to do cleaning. Dust alone can make you to lose a proper connection, especially in some electrical system when they use all these connectors. I know many of us actually use a connector, just to actually connect supply from one particular joint to another. So when you use most of this connector, try as much as possible to make sure that the place is well dusted. So in most cases we use water, and then we set it to a very good or moderate pressure, so that it will not affect most of the things that the wires that are dangling and all that. So we direct it to all those joints or all those junctions that you know that you have done some connections where there may be dust already covering the conducting area and all that. You direct it to that place, you blow away you blow up the dust, you make it clean, perform cleaning. Sometimes some people use some people use this compressed air that I mentioned of. So electrical system also must be well lubricated. Okay, and those lubricants are actually what being applied to the moving parts, like I explained about frictions and all that. So you also apply what lubricant to the bearings and to the gears. Some of them are also using what gears. You will apply what, the bearing must be lubricated because what is actually what rolling. We have different types of bearing. We have roller bearing. We have the one that is like a needle for very very small. If you know that if the space is kind of tight, they use one needle like a bearing. They are roller bearing. Okay, they are ball bearings. So they must be well lubricated. Use correct lubricants. In every system I've been I've been training on, I've been mentioning that there is a need for you to use, the recommended lubricants. It is very important. Okay. You must also carry out some tests when you are maintaining an electrical machinery, like you test for the voltage. You still want to know if the voltage that is getting to the system is still the required one. Every time we go for our maintenance on electrical system, on our drives, on electric motors, we do this. So you check for the voltage, if it's still giving you correct reading, the current, you test for it, we test for resistance. Okay? And in doing this, we make use of multimeters. You can use the oscilloscope for you to see the variation in the voltage, that's the frequency, for you to actually see it. And there are other testing equipment that you can also use. You can also test for continuity. Okay, I'm going to elaborate on this. You can test for continuity. You can test you can do insulation tests to be sure that the insulation of that the insulators have not been broken down, and that you are not going to be receiving shock from the system. I'm going to actually elaborate on this. I'm just giving it. The corrective maintenance on the electrical system or machinery, that's talking about the troubleshooting, because corrective maintenance has to do with repair. I made mention of that. When the system or a machine runs to failure and you have to repair it, that is, bring it up to function again. That's what we call corrective maintenance. We have explained this a whole lot. So what you need to do is for you to first identify the source of the electrical faults. You need to know what is wrong with the system. Okay, which part of the system has actually failed? That's what you need to troubleshoot for. And then in doing that, you can use some of your testing equipment, or you use the diagnosis tools. You can also use observation. You can, in some ways, so even with power on the system, they want to see if the electric motor is struggling, is struggling, like is trying to work, but it's just like it's struggling like someone that is overloaded. So you can know proper places to actually go, or you can use a multimeter to carry out the troubleshooting. Then you either replace your electric motor or you replace. There are some factories, some companies that I've seen. When the electric motor is faulty, they bring it out and they replace it. But in most industries where I've worked, they will send it to the workshop. So they always have, spare rating of different electric motors. They have them in the workshop. So if it's for instance, if it's 3 kilowatt motor so that they can guide against downtime. If it's 3 kilowatt motor and they couldn't repair it on the spot, they kind of just rack it out, uninstall it, go to another one immediately, install it there, and take that one to workshop so that they can work on it, repair it, and make it ready next time they have to replace another system. So that's how they actually repair. So sometimes you may not be able to repair on the spot. You have to replace it immediately and repair that one. If it's something that you can repair, especially anything that has to do with the windings of the electric motor. It has to do with the windings of the, and how do you see any of the electrical machinery that is not actually using drive, or that is not using electric motor? You deal with them. Your fan, okay, it has a motor that is actually controlling it. Your, what is it called? Your fan belts. Okay, it has an electric motor. There is also what controlling it. So anything that has to do with rotation, mostly across industries, they're actually using what drive. So you should know that what you can replace immediately and repair that one later. So there should always be space. So you can also use the OEM. We call OEM the original equipment manufacturer. That's OEM. So you can use OEM or equivalent parts to ensure compatibility. So the original equipment manufacturer, they will do this. If you use them, if you consult them, you need to know which spare part is compatible. That's what OEM is actually functioning, is meant for. You need to know which part is compatible with the machinery that you are dealing with. So that you don't go and put the parts that's supposed to be in Honda and then you are using it in Toyota. That's what we are talking about. So you need to consult what the original equipment manufacturer. Okay, you use their information. Okay, you use that information for you to actually know what to replace in the machine and the one that is compatible with it. So you must use what is compatible with it. There are different kinds of bearings. You can't just carry any out bearing and say, oh, the bearing is bad, and then you want to blow the bearing. Okay, if it's capacitor that blew off, there are capacitors rating. So you have to check the rating and replace with the correct rating. If it's the fuse that blew off, if it's a 15 amps fuse, you can't go and take 20 amps fuse and put it in the system. Many people do this, and it is wrong and dangerous for the electrical machine that you are dealing with. Because the implication is that if the 50 amps fuse is replaced by 20 amps, so before, if any current that is above 15 amps want to pass through the system, what the fuse will do to blow out. That is what the fuse is just like a suicide bomber who will actually commit suicide. It will kill itself instead of your system to actually be damaged. So the fuse will blow out. So you can now imagine if you now increase the rating to like 20. So it means that it's a system that's supposed to take more than 50 amps current. Now, if 60 amps current is actually flowing through it, it will take it 70, it will take it 80, it will take it 90, which is dangerous for the system. Until it reaches 20 before it can actually shut down. So it's very important that you use the proper rating, okay, the correct spares, the compatible spare parts, to do your replacement whenever you are doing replacement. Do not join those league of people that, a lot of people take all those risks. They just say, okay, if I use this, it will work. Yes, it may work for a while, but trust me, it actually endangers the stability of that machine. Okay, rewiring or reconnection. Before you rewire, before you reconnect, you need to actually try to check the wiring diagram. Hardly will you see most of our machineries or machines in across industry. Hardly will you see any one of them that does not have their wiring diagram. So we are not skillful in reading it. Okay, the electrical, the trained, the electrical department, workers must be able to read the wiring diagram. So it helps in troubleshooting. So you will know where this is coming from, where this wire is coming from, where this one is connected to this and that, and then you know where to be putting your multimeter probes for you to check if it's continuity testing that you're actually doing. So it is very important. Ensure proper connections and wiring practices. If the connection is not tight, sometimes you can be having what we call partial contacts. Partial contact is that the conductor will make sometimes, and sometimes it will lose. It will make, it will lose. So that will cause fluctuation within the system. And it will be as if, in fact, I have a very, very horrible experience with my car battery. There was a time I had a very bad day. It was a very bad, in fact, since my history of driving, I think that day was still the worst, I could say. So what I was facing this day was that anytime I'm driving, I would just notice that when I enter into gallop, so whenever I enter into gallop, my car will just stall. That is, it will just, the light of the first thing I will observe is that the steering wheel is very hard to turn, and then the dashboard lights will go off, and then my car will just go off. And you know, driving in Lagos, you know, that kind of experience in Lagos, you know, it may actually stop on the even their horn behind me. Get off, get off. I was so tired. I will get down again. Okay. Hold on a bit. I'll start the car again. The car will move to some distance. Once I get to a place where, you know, I enter into gallop again, it will happen. So at the point, I check, what could be the issue? Okay, no one is overeating. And fortunately and unfortunately, coincidentally, I checked. I saw that one of the fans was not actually working. Okay, I put off the AC. I said, okay, maybe without the AC, it will actually work. I moved, you know, my wife was in the car. We were going for an event. My car, you know, was just stopping, you know, pulling off to the extent that many people that live in Lagos, you know what I'm talking about. There are some places where your car should actually stop. Before you open your bonnet, you have to settle the boys, the area boys. They must collect money. I paid that day, you know, because, you know, there was one stoppage I faced, even around the show here. So it was a way. Listen to all this thing I'm actually telling you. Do you know that same day I used an emergency mechanical workshop? They do so many things on the car because that's not the workshop I normally use. They do so many things, serving the poster, serving this, it may be this, it may be that. They do so many things. I spent about 3 hours there. Just, you know, when they handed over the car to me, I've not driven for like 20 minutes. The same thing happened. So I have to manage the car. You know, that day, I reached my house, called my normal workshop, and he told me that I should just find my way to get the car down. Even if it's just stopping on the road and all that, I should bring it the second day. In fact, they sent one of their guys to come and drive the car to my workshop. Do you know that the only thing that they did on my car, that they troubleshooted, is that I had a loose connection on my battery. The only fault that I suffered for that day was that I had a loose terminal on my battery. And I checked that day. I couldn't figure it out that it's a loose terminal. I said, no, it can't be a loose terminal. With that problem I faced, I argued with them. It can't be a loose terminal. This ain't a loose terminal because I left my car there for like 2 days. I fueled it. I said, okay, fine, just test it once. I want to be sure. The guy tested it. He said the car did not stall on the road. That he's very sure that it's just the news terminal. Everything is all right. And trust me, I've never, that kind of scenario has never repeated itself. Ever since that day when they changed the terminal of my battery, tightened it where I got a battery seat that will fit in properly. They tie it down. That even if I enter into gallop, there won't be anything like shaky terminal. I never experienced that kind of thing again. And that's the kind of problem that loose connection can actually do to you. If you are working in industry and you have never faced the issue of a loose connection before, you will not understand what I'm talking about if you are in the electrical department. It has really, you know, I've experienced it a lot. And it can scatter the system of any machine. Which having, you know, just imagine that somebody is fainting and waking up, fainting and waking up. That's how loose terminal actually works. Somebody is fainting and waking up, fainting and waking up. You know, it's entirely to the system. So you can disorganize every other thing in the system. So partial contact is that it's making, there will be supply, it will shake, supply will go off. So you have to tighten all the terminal properly. It's very important. Now, what are the common issues that you may have? The common issue is that I've told you, most of the electrical machines, they suffer from overheating. Okay? Overheating of the system. Okay? Electrical component overheating, wiring or connection overheating. So you have to look out for this. Short circuits. Short circuits happens to be in the conductor carrying live. That's the live conductor. You know, short with the with the ground. That's the neutral. Let me try to bring this up. Let me bring up my whiteboard so that we can see what I'm talking about. I don't want to assume that we are all electrically oriented. Okay. Okay. So, of course, you know that even the mechanical guys know that. So there is always live, there is always neutral. So if this actually was short with this, that's what we are talking about, short circuits. So if this wires that are supposed to be parallel to what each other, they're supposed not to meet. So both of them are supposed to go like this. But in case of short circuit is that what both of them now touch. That is short circuit. So that you can look out for that kind of fault. And it can happen when there's overheating. You know, there are some wires that they pass through the same pipe, okay? So there is a pipe, okay, and you run the wire through them. So if there's overheating, one of them or both of them can lose their insulation. So if the insulation peel off, the insulator peel off here. So if these should short together, there will be short circuits. So and unless you are able to actually what troubleshoot and see that what there is continuity. So when you perform a continuity test between the two wires, there's a way you can perform what the continuity test between the two wires, and you see that what there is a flow or low resistance between them. So it shows that they are touching something. You have to trace that wire or trace that connection and resolve it. So that is I'm going to actually what elaborate on that when I'm talking about using the multimeter for testing. I think I will elaborate on it. Okay. My slide is back. So check out for corrosion. Okay, the corrosion of the component, electrical component or the wiring component. The power quantities also in most cases. I had a very funny experience with this. There was a time we were resolving a fault, okay, on frequency drive, okay. So we were resolving it, and anytime you are working on it, everybody that has worked on that equipment before will know that instrumentation will come, the power will come, that's electrical will come. So most of the problems from VFD in most cases is actually what the instrumentation aspect, because it has to do with the electronics aspect. Because the only thing that the power will do is for them to test the voltage that is going into the input. So once they test the voltage and it is the correct voltage that's supposed to go in, and they will now go outside and see that what it is not giving what maybe the correct voltage is supposed to give out. That means that there is a problem in the electronics system. So they have to, because VFD is used to vary the speed of electric motor. So they use it to vary the speed, and in most cases the system it uses that what when the AC come in, they convert it to what DC, and then they alter it back to what AC. So in that case, you are already what altering the frequency, and then altering the frequency will affect what we also alter the speed of the electric motor. So the horrible experience was that the power guy came, we were there, we were the power, and the instrumentation was like, hey, he tried that he didn't know the fault. So he said it's a power issue. We just carried the multimeter and then we tested it for him. Say, see the voltage. So when he saw that it was correct voltage that is coming, then I don't like the voltage. I don't like the voltage that is coming. The Indian guy that led us have to burst into what last and you don't like the voltage. You are seeing the accurate voltage, you don't like the voltage. So voltage, does voltage have a skin color? Does it have skin color? Do you have black voltage or white voltage that you say you don't like the voltage? We were just laughing because he was actually confused. It used to be, one of the instruments that normally give the instrumentation department, normally give them headache a lot, okay, to troubleshoot and resolve in the company where I've actually worked. So we were just laughing at it. How will you say that you don't like the voltage that is coming in when you can see that it's the correct voltage? So you have to check for voltage fluctuation in most electrical machines. The problem usually is what the voltage fluctuation. If the voltage is not steady, okay, That's why you see some electronic gadgets that use what steady, just to they use a stabilizer, you know, all these TV that you use in your house and everything. Most of them are just to what stabilize what the voltage that is coming, because the equipment need a steady voltage in order to function well. Okay, so you see all these your freezer that use a relay and all that. You know, the relay or those transformer that use a tap changer just for them to actually adjust. Depending on the input voltage that is coming, the tap changer will just adjust itself so that it can produce a steady output voltage. So the voltage has to be what steady. What are the tools and equipment that we use? We use multimeters. I've explained this. Oscilloscopes that is used for you to actually measuring what or to monitor this voltage variation in the voltages. So it will display this like a graph for you, like a waveform graph. You see the fluctuation in the voltage. Or some people will say it is used to actually measure what frequency, just for you to know how stable the supply is and you are disturbing the signals that is actually coming into the system is. So we use thermometers, okay, to measure what temperature, because I explained that what most of the problem with electrical system or machines is what overheating. So you have to monitor the level of what temperature. Excuse me. So every system has the temperature that it can actually what withstand. It has the temperature that it can withstand. Samodito, are you there? Okay. What are the safety precautions? Okay, your people, we have mentioned this, your motor remain safe, your electrical what safety, like following the electrical, the working, the procedures. You have to follow the procedures. If the confined space entry, you must also follow it. The best practices is that what manufacturer's instruction, I've made mention of this, proper tools, the personnel should be what trained, and then you must what have what the procedures being what documented, and then we have some regulations and standards. In when we are talking about electrical machines, most cases across industry, what you have is the motors and the what drives. Okay, you have the motors and the what and the drives. Okay, so because without the if you have any moving parts that you need to, if the machine was actually what move, definitely there must be what motors that is actually what electric motors or drives that is actually driving it. And all these preventing maintenance that we have earlier mentioned about electrical machineries also stand with them. The corrective maintenance what is also what applicable to them. In your drives and your motors, okay, what you can actually what have as common issues that what there can be overheating. I've mentioned that generally is applicable to electrical machines. There can be drives overheating, motor overheating, vibration. In most cases, your motor will vibrate because there is always coupling system. Coupling system is all. If it's not coupling system, the motor is being mounted. That's the stand on which the electric motor is actually being mounted. If it's not stable, or if it's actually sometimes it is bolted to the ground. If the bolt has removed, there will be vibration in the electric motor, and that will affect the proper and smooth running of the electric motor. So you have to check out for vibrations, misalignment. There may be misalignments. Okay, it happens a lot, especially if it's a bed coupling, if it's chain coupling or anything like that. So there may be misalignment. So you have to check for misalignment. In conveyor belt misalignment, there are some sensors that they normally make use of. Like in one of the companies where I work, we have what we call sway sensors. So that sway sensor is just like a plunger. Let me show you how it looks like. So we call it sway sensors. Sway, so that the belt will not sway off. So here this is the belt. So we have the sway sensor that is actually what being mounted around here. It's not that you are putting human arm around here. Okay. So if those beds should swing towards this direction, it will turn. There's no way it is possible that if the bed actually was shift, the bed is really on rollers. So it is rolling like on drums. So this is the bed there's a roller beneath it. So if this bed should shift to this direction, it will actually what? Touch this way, this switch. It will turn it. So when it turns it, the output is actually what? To any alarm or to any trigger. So in most cases, the interlocking, when we're talking about interlocking is done in electrical wiring such that what you can actually have the safety of the machine. For example, okay, let me try to break this down. Okay, let's say we have these belts. This is conveyor belts. Conveyor belts. Okay, this conveyor belts. And this conveyor belt always what? Maybe the material that is coming will actually what? Will fill up this place. And that material supposed to be passing through these chutes. We call it chutes. It's supposed to be passing through these chutes, okay, and land on another bed that will take it to another unit of the company. So you can see this is the section A, this is the section B. In this section A, the material is coming in, it will pass through these chutes, it will fall inside these chutes, and from that chute, it will be falling on another bed that will carry it. So there is a way we can put a level sensor, because sometimes this material can actually clog around here, such that it will not be dropping on what? On this bed B. It will not be clogging like that, like something is blocked, and the material that is coming in will not be heaping up, it will be heaping up. So there's a way we can put a level sensor here. Maybe a level sensor, something like that is using proximity sensor or level sensor that is actually sensing the height of this material. Once this material has came up here, so we connect the output of this sensor to the electric motor that is driving this bed, such that once this sensor is giving an output, it will switch off the electric motor that is controlling this bed A. So the bed A will switch off immediately. Why are we switching it off? So that more materials will not be coming here and it will not be wasting or be falling off. So the process guy will compulsorily have to come to this unit, they clog this chutes, make sure that when the chute is free now, and now when it becomes free, they can now tell the control room, they will power up again and the system will continue running. So we use it for interlocking that if there is a problem in this particular unit, let this particular unit be switched off. So we can say if there is a problem in what? Unit B, unit A, the switch off. So we call it interlock. Interlock. That is, you are locking them together so that there will not be a problem or wastage along the line or any threat to safety of the equipment or to that of the workers. So the same way that's how that switch also works. Because if these belts should actually sway away, all the material that is here, they will waste. Sometimes the process guy will have to come and manually be packing those material. Okay, so what they do is that once this belt is swaying, that is dripping off the drum on which it is being driven, is dripping off it. It will touch this switch, and this switch will activate, okay, an output that will switch off the electric motor that is driving this belt. So this belt will have to the electric motor that is driving it will have to go off compulsorily. Now, when we come there, we will see that the swing belt is actually in fact, the switch switches that you have here, the fault, the error will show on the system at the control room that the switch is this particular switch with code number so it must have had its own identity number. They will go and see that the belt is already swinging. They will adjust the alignment of the belts, okay, align the belts, okay, and return the switch to its normal position. That is when they can power on. So this alignment, or coupling system is very big issue that you should work out for when it comes to electric machines. So let me bring up my slide. If you are with me, please give me thumbs up. If you are still with me in the class, give me thumbs up. Hey, my people are with me. Thank you so much. Thank you so much. Thank you so much. That's great. Thank you so much. Yes, we are moving with a very good, we are moving with a very good speed tonight, so it's fine. So I've discussed the tools and equipment. The vibration analyzer can also be used. The safety aspects remain the same. What is the best practices? Follow the manufacturer's instruction, use proper tools, train personnel, document procedures, and then examine the standards. So I've discussed all that. So the electric motors also, we have different types. We have direct current, okay, motors. These are the ones that require steady voltage. We have the AC, that's alternating current. I don't want to be going into that, but I've done a lot of analysis for you in the material here. Okay, I don't want to be touching the theoretical aspects of it. So, but the one I want to talk about is the inspection, the testing. Okay, what are the testing that you need to actually carry out on your drives or electric motors? There's what we call no-load testing. I think in the first day of the class, I briefly mentioned this. No-load simply means that what you will disengage the electric motor from the that is actually driving. You will and try to actually run the electric motor and observe it, listen to how it sounds and everything. So with that, you can, if there's any problem with it or not. Let me give you an illustration of that. Sometimes when you perform a particular maintenance on your car, okay, you may be at a spot. The mechanic guy will tell you to raise it. You say you should raise your car. You want to listen to how it sounds, okay? And after you raise it on no AC, they will not tell you again that you should actually put on the AC. They want to listen to the engine, okay? So if the engine is fine, or if you are driving automatic, if there is you don't want to test for the selection of your gear, the automatic gear, they will actually have to fire your car just to drive your car around to see if it will be changing gear automatically. So that is the way they actually do all this test. So you can do a load testing. So test the motor without a load, so that you can check out for unusual vibrations, noise, and overheating, just as I've mentioned. You will now do what we call load testing again. So in load testing, you are going to actually now load it. Couple that the electric motor is driving, couple it with it, and then you observe it, okay, to see if the rotation is fine, if the torque is fine, that's the spinning, the rotation is actually fine, that's the movement, okay, is actually fine. I don't want to go into too much theory with that. So you check the efficiency and all that. You also test out the insulation resistance. Okay, you test for the insulation resistance. I will come back to that. I'll talk about that when I'm talking about testing with a multimeter. Okay, I'm going to explain that. We have an overwhelming. So another electrical part that needs maintenance is your VFD. I've mentioned this. I said VFD is actually used to actually alter the speed of your electric motor. There are some electric motors that you don't drive them on a steady speed. For instance, let me use my experience. Okay, back then in the cement factory where I work. Okay, we have a conveyor belt that runs from mines. I think about 10 kilometers. 10 kilometers. So that conveyor belt. So let's say this is mines. This is the mines. And this is the factory, very far from the factory, very far from the factory. So this, when in the mines is blasting of limestones and everything. So the blasting of, in fact, that's where the raw materials we use for manufacturing of the cement. That's where they are. So there is a conveyor belt from the mines. I just want to tell you, because these belts actually make use of VFD. They use VFD to drive these belts. And I want to tell you some kind of equipment that make use of VFD. So materials will have to come from mines, okay? And then, these materials will be go to what we call mixed storage. That's where they actually store them, mixed storage. So sometimes there may be production in the factory that all the storage that we have in this mixed storage, we have almost exhausted them, and they don't want production to stop. They want production to be going on. So what do they have to do? They need materials urgently and very fast from mines down to the factory. So in that case, they need the electric motor that is driving this bed to work at a very fast speed. So that is why they need VFD there, so that if you want it to work on a fast speed, okay, you can achieve it. If you want it to work on a slow speed, and I will tell you, this is the case where we need material, and this drive has to work very fast, so we need a fast speed. Another way, it might be that the production is going on, and the new storage is already filled up. The new storage is already filled up, and yet the material keep coming from mines. They are still blasting, they are still sending us material. So what do you want to do? We don't want too much of a materials again, because the material in the mixed storage is already, we have enough of them. So we have to drive these beds at a very slow speed, so that the material will just be coming, will just be dropping little by little. It will not be fast. So that is why the electric motor that is driving this, they couple it with what? VFD, variable frequency drive. Some people call it VVFD, variable frequency drive. So what we are doing from varying the frequency is that we are varying the voltage, almost like doing the same thing. So when you vary the frequency, okay, definitely there will be variation in the voltage, and that will affect the speed. Either the speed will be high or the speed will be low. You can compare this one to the way the fan regulator works at home. Okay, even though this one is just resistance, we are just adjusting, just like you are making use of rheostat in a particular system. That's a variable resistance. So if you put it on 1 or 2 or 3 or 4 or 5, what you are simply doing with your fan at home is that you are either reducing the resistance, and we know that the lower the resistance, the higher amount of current, of current will flow. And when the resistance is high, small amount of current will flow. So resistance is actually what opposes the flow of the current. So if you put it on 1 and the resistance is highest at 1, then the speed of your fan will be lowest at that time, because only little current will be able to flow through. But when you set it to 5, let's say 5 is where you have smallest resistance there. So it means that enough current will be able to flow through, and there will be enough flux that will be generated, and there will be high speed. So interwoven, this thing is just like is interwoven. I'm just using the domestic example for you to understand how it works in the industry. So that kind of equipment, which is VFD, we use to achieve variation in the speed of the electric motors. Of course, we know what electric motors are. We use them to convert electrical, to mechanical power. So we are converting electrical power to mechanical power, okay? Based on what we know as the conservation law of energy. Energy cannot be destroyed or not created, but can be converted from one form to another. So you are converting the electrical to mechanical in such a way that now the input to electric motor is electrical power, but the output energy that we are having is the mechanical power. It's either driving something, maybe a conveyor belt or a chain or a particular thing across in the factory. So maintenance of these also follow what we have actually explained on the drive. So you check for signs of wears, the damage. Let me bring up my slide back. Oh, I have some other thing. Can you see my slide? If you can see my slide, please thumbs up. I've brought back the slide. Thumbs up if you can see my slide. Thank you so much. Thank you so much. Mr. Moderator, are you there?
Yes, I'm here, sir.
Okay. So, the preventive maintenance on a VFD, check for signs of wears, the damage, overheating. Okay, these are general things that you look out for. The wiring, the connections, and all that. I don't want this to. So it's just like the same thing that you do on drive. I've explained all of them. Overheating. Okay. The safety aspect is still what? The same. In industry also, we also have the maintenance of sensors and actuators. Okay. Is there anybody here who can give me a name of a sensor in your company? A sensor in your company that you make use of very well. There are different proximity sensor. Proximity sensor, thank you. Proximity sensor is very common. Okay, proximity sensor is very common. They want to know if this thing is actually was still in the position or not. The meaning of proximity sensor. Emmanuel, you have one that you wanted to mention? Capacitive sensor. Okay, thank you. So we have a whole lot. We have how many of us have? You have
reflective sensor. Reflective sensor. Reflective
level
sensor.
sensor, right? Do you make use of level sensor in your company too?
Yes.
Okay. Level sensor. Yeah, thank you. Thank you. So we have maintenance of these sensors also. Okay. Actuators. What are the use of actuators? Actuators are actually what is the component of the machine that is responsible for movement. Okay, so it's actually the one that will convert the energy source, whatever the energy source of the machine is, this that is converting it to mechanical energy, which is the movement. So actuator is the one that causes movement in the machine. So we maintain them also, and their general maintenance also is not far-fetched from what we have discussed so far. You have the cleaning, you have to clean your sensors. In fact, most of the problems that you have with sensors is when they are covered with dust. By that proximity sensor, it was on the infrared, the one that is using infrared, that is using lights. You have to clean it. There must not be dust, actually what? Covering it. It's very important. So you clean it, you clean both the sensor, you clean the housing of the sensor. Okay? Because of damages. Most of them are always being housed in a case. So you clean that, their casing, you clean the sensor itself. That sensitive part of it, you clean it. And in cleaning, you must not clean it with material that will damage it or that will scratch it. You must clean it, it's just like something that is delicate. Okay? The calibration is also what? Important. You have to calibrate your sensors according to the manufacturer instruction. Please, come on, take care of that. All right, thank you for your cooperation. So ensure that it is well calibrated. Your inspections about the wear, about damages. Sometimes your sensor can be damaged. Okay, there was I think it's my car, because what they had to do in the workshop for me was to just bring out a particular sensor. Okay, it was really giving me issue. I think there is a shock sensor. Shock sensor. There is a shock sensor, in some cars. My car also have that shock sensors. I don't know. But on this modern car, there are shock sensors there. I think they have to work on my shock sensor that because it is covered with dust already. Okay, so most of these sensors, they will not work properly if there is dust, if there is damage on them, okay, corrosion on them. And in most cases, when they are down, you have troubleshooting, you see that it's actually the sensor that is giving you a problem. Replace them. In fact, I hardly see where they actually want to repair sensors in the industry. I hardly see when they have to repair. In most cases, they replace them if you want to have an accurate result. Okay? Don't forget to also consult your OEM. That's original equipment manufacturer. So actuator maintenance. Actuator maintenance, you have explained that what it is the actual part of the machine that causes movement. So when I mention movement, you should know that what you are going to need what lubrication. So you lubricate. Actuators must be lubricated. You must actually what inspect them, okay, for the sign of since there will be friction, in them, there could be possible friction in them. So you have to check them for wears, damages, corrosion, okay. You test them also to test out what their performance, and in most cases you replace them when they are giving you what issues, okay. The common issues with your actuator, drifting or inaccurate what movement, okay. There was a time I was driving and I was feeling the vibration. You know that definitely that something is wrong. When you are working with a machine and you see that what is moving, the actuator is actually the movement is actually happening, but you know that what the movement is not normal. You will know because that's not your first time of using the machine. It will be an irregular movement, so you should watch out for that. That can also go to faulty wiring. You should check out for faulty wiring or faulty connections. Now let's talk about testing equipment. I'm going to really discuss what multimeter because I want to give enough time. I really want to give some time for us to discuss. I need questions. I need feedback tonight. Moderators, we have to also address you on how to go about your assessment and all that. So I don't want to use my time like on dots. So testing. Let's talk about testing, and that's the multimeters. What do you use your multimeter for? You can use your multimeter for different electrical testing. But since we are a mechanical person online even tonight, so we look at it together. We use a multimeter for measurement of voltage. You can use it to measure voltage. Okay. You can use it to measure voltage. You can use it to measure current because these are the things. These are the parameters that you must actually measure for you to know if your electrical machine is working fine or not. So you have to know if it is working under correct voltage, okay. And we have different. You can have the one that is digital, your multimeter. You can have the digital one, or you can have the one that we call scale. Okay, the one that is using scale. Okay? Analog. Yes. We call the one with scale analog. So I want to see if I can actually display the two of them. That's what I'm checking. The digital and the analog. Let me see if I can display it first. So I can use that one for explanation. Okay, so this is the digital multimeter. Okay, and this is your analog. Okay, multimeter. So that one is actually using is working based on scale. But not to disturb yourself, I recommend that you use your digital because you'll be able to see. It's not like you're having issues with your site. You need to see the number that you are actually measuring. What we just want to explain is that how do you use this to measure your voltage? How do you use it to measure your current? How do you use it to measure your resistance, your continuity test, and all that? And why do you need all this? So that's what I'm going to, let me use my whiteboard. So as you can see, you have your probes. You have what we call your probes, okay? Your probes is what you use to actually touch what you actually want to test on. Let's say, for instance, we want to test for, let's say there is a connection here, live. This is neutral. So we want to know the voltage that is actually in this machine. This is a machine. Okay. So in your multimeter, okay, you will see that in your multimeter here, okay, I don't know if this one is, but of course you can see V here. This is V around here, okay. So if you see, you can use it to test for voltage. That's what we call it multimeters. Multimeters means that you can use it to test for multiple parameters, electrical parameters. There are, you're talking about the instrument that you need to use to test for your voltage. That's voltmeter. The voltmeter you will use. This instrument that you need to test for your current. It is a ammeter. If you are looking for instruments to use to test for your resistance, it is ohmmeter. But we now have one that is like built for all these parameters. So that's what we call it multimeters. So when you are using multimeters, you need to, whatever parameter you want to test for, you must set this your knob. You must set it to that parameter. So if it's voltage that you want to actually measure, you have to set it to that voltage. And don't forget, if you are setting it to voltage, you should know the kind of voltage you want to measure the system. Is it an AC or an DC or a DC? That's what we now talk about your probe. So look at these holes that you are seeing here. These 4 holes here, okay? These 4 holes, they guide you to actually put the 2 probes that you have. The probe look like something like this. This is your probe, okay? So you can see the wire around it. So it has a ball or pin mount, okay? So your probe will go into, that's the red one, okay? The red one will put it in the terminal that reads something like V. Some of them will show ampere. So the red probe will go into this particular place. You connect it into this place. And then the out just manage that. So the other O, you see it as common, which means grounding, or your negative aspect, or the return for the flow to complete the circuit. So you put your black, this is your red, you put your black, okay, in this. Your black probe, you put it. So this is the two out that you will use to touch, either this and you touch this. Don't forget, while you are doing this, your knob has already been set to the voltage you need to measure. And you should actually know the quantity of the voltage that is specified on that system. So it's also on your multimeter. So that if you want to test for, let's say, something that is more than 200 volts, and you are now setting your probe to where they reach the maximum of 150 volts. So you can see that you will damage that multimeter because the amount of voltage that you have set to is lower than the voltage that will flow through it. So you must set it to a correct voltage for that particular measurement. So you put it here, and then with your digital or your analog, it will display the voltage in the system. Now, when you are testing for voltage, you should know that testing of voltage is done on a live circuit. Live circuit means that the system is powered. It has to be powered. Okay, so you don't test for voltage on a dead circuit. You test for voltage on a live circuit. The same thing you will do when you want to test for current. You go back to this your knob. Okay, you look for current. That's the ampere. Like you look for it. Okay, it's somewhere down here. So you set it to either your red probe will be. Your red probe will go to either you set your knob to either DC, current, so you see it as DC, or AC current. So if AC you are measuring, your knob should be set to what AC. Means what? DC you are measuring, your knob should be set to what? DC. What I'm mentioning this is that you have to be very careful. Make sure that the parameter you are measuring is what you set your multimeter to. If not, you damage the multimeter. A lot of cases like that. For so many people that don't know how to use multimeter. So you check that parameter. Make sure you set to the knob to the correct measurement. And then you use your probe for the current also. will still be on this. As you can see here, it can measure voltage, ohms, which is resistance, or your ampere, which is what current. So milliampere. So it can actually measure it. Your red probe will still be there, and your black probe will still go to com, and then you measure it. Again, you can test out for current on live circuits. It is only when you are testing for your resistance that you need to actually make sure that you are working on a dead circuit. You are testing for resistance. Test it out on a dead circuit. That is the circuit should not be powered. And why are you testing for resistance? You need to see what amount of current that will flow. That resistance is high. It means that no current will flow through it. And if the resistance is low, it means that higher current will flow through it. And when you are setting your knob, that's your knob, you set it to your ohm. You will see a symbol like this, okay, which is your ohm meter. Okay, you set your knob to that ohms, and with the correct rating, also check it. What is the rating that are there? Is it 50? Is it 100? And you know the kind of the resistance you are expecting from the system you want to measure. So you set to the correct measurement, and then you test out resistance. Another test that you can actually carry out is what we call continuity test. And in most cases, continuity test skill is very, very important. It is very, very important when you are troubleshooting. Why do you have to test out for continuity tests? There are some times that maybe you have a supply here, okay, and the machine is here, okay, and the measure from the breaker, the power actually enters into the supply. It enters into the breaker that you're actually using. So the supply enters into it. But the machine here, anytime you power it up, it's not coming up. So this is the conductor, okay, that leads to the machine. This is let's say this is live, this is neutral. Okay, this is the machine. So you put your multimeter around here. You see that it is actually giving you correct readings. When you come to the machine, the supply is not reaching machine. What could be the problem? Of course, if somebody started a journey, God forbid, and you call the person's destination, they say the person has not reached the destination. What happens? The person will still be on the road. So it means that our current is actually trapped somewhere on this conductor, and it's not getting to the machine. So in a case like that, you want to test for continuity.
Low battery. Please charge.
So you may have to open the wire around here. Okay. You open the wire around here. You first test from point A to point B here. You put your probe. Okay. How do you test for continuity? Go back to your multimeter. Let me see if it's clear. You will see a symbol that looks like a symbol of your diode. Let me draw it for you to see. You will see something like this.
Low battery. Please charge.
That to get a continuous flow between them. So you set your knob to something like this, to this continuity, okay, and then you put your probe also, okay. Properly, you set it to continuity. You put your probe on that particular your red probe should be put on this. When you see this
low battery. Please charge.
Put on on the black should actually be put on on COM also. And then you come here, you put your probe here. Any of the probes can be used. You put one here, you put one here. So if the multimeter beep, or if there's any low resistance being read or displayed, it means that there's continuity between here and here. That means that your wire does not have problem from point A to point B. You put another cord here, which is point C. So you test.
Low battery. Please charge.
So if there's any continuity. Anyway, you do not get any beep, or you get a high resistance, it means that there's no continuity there. So this wire already has a problem around this place. Either you cut it off here, you replace it with a good wire, you join it, or you completely replace the length of this wire, okay, and resolve the problem. So continuity, multimeter, using of multimeter.
Low battery. Please charge.
important when it comes to electrical maintenance, electrical preventive maintenance, electrical corrective maintenance. When you are repairing, when you are troubleshooting, it is very important that you should be skillful in it. I've promised not to use all my time, and I'm tempted rather to use another 5 minutes. So let me try to bring everything together. Yes, we have done well. I think I've touched mechanical, the control system, the electrical, hydraulic, and pneumatic. So I want to appreciate everyone. Yes, you will have the rest of the analysis in the material. So I want to appreciate everyone who have explained about short circuit, the ground fault. Okay, let me briefly just explain this. Another issues that many also normally have with electrical system is in the case of the grounding and the earthing. There is a big difference between earthing and grounding. Okay, grounding is when you connect the conducting part of the conducting parts in a machine. If you connect it down to the earth, okay, that is grounding. Earthing is when you connect the non-conducting parts. Okay, let me see if I can bring something up for you. Earthing is when you connect the non-conducting part of a machine to the ground. Okay, and the main purpose of doing that is for you to prevent shock. Okay, it's for you to prevent shock. I want to see if I can actually display something, okay, that would show you earthing and grounding. Okay. Of course, many people normally mistaking this. They will take maybe the earthing and the grounding, but they actually what's different. Grounding, you connect the conducting parts of the machine. You connect it to the ground. Now, the major purpose of doing that in electrical is just for you to balance the load. Okay, if there's any leakage current, so that we will not make the load to actually balance. Okay, you connect it to the ground. But why do we normally connect the body also to the ground, which is earthing? Because of shock. In case you can have the conducting parts, perhaps maybe if the insulation fail and it's actually touching the body of the non-conducting. So now the non-conducting is now conducting. So when we connect it to the earth, that is when we hurt it, it will prevent shock in case if the operator mistakenly actually touch that part. So this is very important also. So you check when you are maintaining your electrical machine, you have to check the earthy parts and also check the grounding part. It is very, very important so that you can be rest assured that as the maintenance engineer or as the employee that is working on it, that your safety is actually guaranteed. It's very important that you should look out for this. So moderator, I think I should stop there. I want to see if I can give us an image of the earthing. I love to be practical with that. Let me share my screen. Let me see if I can show you an image. Okay, I think I got one. So can we see my screen? Can you see my screen? Can you see my screen? So you can see earthing here. So you can see earthing. So you see this pipe now. This pipe that you are seeing is just the body. It's a non-conductor. This pipe is not expected to actually conduct anything. So that wire that is connected to it and earthed is just in case, because this pipe here is housing the electrical conductor that go through it. So it's not expected to conduct. But let's say something happened. Let's say it rained and the insulation failed and all that, and it's now conducting. So what do? We hurt it so that there won't be anything like shock. But you see the other one, grounding. You can see that those cables that we use for grounding, they are connected on the conducting part. and they are connected straight to the head, so that there will be load balancing. Okay, there will not be disbalance in the load, and at the same time, it's also, you know, indirectly also protecting you from shock. So it is very important for us to also note that. So thank you very much. I want to appreciate you once again for being patient with me. You know, as a trainer, I know I talk too much, Abby. Thank you so much. I appreciate everyone. So, Mr. Moderator, over to you.
All right. Thank you very much, Mr. James Fani, for that wonderful session. Yes, it has been a very, very engaging 3-day class so far. So, very big thank you to you, Mr. James. All right. So, quickly, let's take questions. So, please, let's kindly indicate, signify by raising your hand if you have questions. So just signify by raising your hands. So questions from the previous classes, from today's class, and let's see what we can do before within the next 15 minutes while we prepare to wrap up the class. Okay, questions. Please signify by raising your hands. So those who, if you're in a place you can't use your mic, just drop it in the comments section. So those joining on the YouTube live, joining via the YouTube live, so please drop your questions in the comment section as well. So let's see what we can do. Let's see how far we can go with them. Questions. All right. So let me check from our YouTube channel. Okay, so far so good. No questions from the YouTube channel. So I think we are left with the classroom participants. Oh, okay. So yeah, I guess the class was quite understandable then. It's good. It's been a long while that we don't really have questions like this. Okay, how can I join the WhatsApp group? Mr. Vincent Chinedu, I think you requested for the same thing yesterday. You've been added to the WhatsApp group already, if I'm correct. You've been added to the WhatsApp group, so please check your WhatsApp. All right. So someone is asking. Hold on. Let me see if I can bring that up. Please, can we get the lecture manuals while we are planning to get the certificate payment? Yes, you are going to get the lecture manual, but the condition is once we are sending out the certificate, that is when we send out the lecture manuals alongside. So we send it together with the certificate. Yes. So that's how it works. All right. So please, my observation. Okay. That has been. Dryer was not mentioned as part of the pneumatic. Okay. Well, like the trainer did mention, he would mention all the pneumatic machines or equipment that we have. We can't mention. It's just the principle guiding them. The principle of maintenance guiding all of them are actually similar. So I think the same principle applies to when you are trying to maintain a dryer as well when it comes to pneumatic machines. All right. So okay. So I think on that note, yes, we are good to go. We're bringing the class to a conclusion. Okay. So the informations needed, the assessment is going to be dropped on the WhatsApp platform. Okay. We do have fluids in some pressure gauges. Okay, so perhaps the trainer is going to have something to say in relation to that. Okay, so we are going to be dropping the assessment on the WhatsApp platform. So please do well to attend to them. So what is required from you in the assessment is a 60% performance in the assessment. So you have to do 60%. If you don't meet up to 60%, yes, you have the liberty to retake the assessment. Mr. Chinedu, you get a WhatsApp number in the message session that you can chat up. So perhaps you'll be added. The number will be dropped in the comment section. So just chat the number up on WhatsApp. So you'll be added to the group. All right. Okay. So aside from you doing 60% in the assessment, yes, it's also a requirement for you to qualifying for the certification as well. So that is what is needed from you. So please let's endeavor and let's try to take it. So there was a form that was dropped for those who are interested in certification. Please endeavor to fill that certificate form. Yes, it's just for us to be able to filter those who we are working on towards regarding the certification for the course. So let's have that at the back of our mind. So every other information that we need, the recorded videos are going to be dropped on that platform as well. We've dropped them, but we'll try as much as possible to post them again on the WhatsApp group. All right. Okay. So please, yes, we also crave your indulgence. Help us to subscribe to the YouTube channel. Yes. Aside from you doing us a favor of growing that channel, we are also doing you a favor, because all the trainings that are there that you don't even know of, just go through the channel. There are lots of interesting classes that you can go there and watch or benefit from. Yes, classes on project management, classes on human resource management, classes on leadership, organizational crisis management, and the likes. There are loads of classes on that channel that you can watch and benefit from. Yes, the certificate is acceptable nationwide. Yes, that is why we are conducting this training. So we have lots of people who have gone through our training and are using our certification out there. So we are not just maybe focused on one aspect of training. Our training is cut across. So our certifications are widely accepted. All right. Mr. James, are you there, sir? Do you have any parting words for us?
Yeah, thank you, Mr. Kende. Thank you, everyone, for this 3-day intensive participation in this training. Let me encourage you, please. As you can see, there are 5 categories of certification in this training. Although I will tell you that in the present, day of engineering, the 5 certifications are very, very important for anyone who is actually in the field of maintenance. So, and I really mean that either you have electrical background or mechanical background, it's good that if you can afford it, you go for the entire certification. But be that as it may, if you cannot afford it, if you are choosing maybe mechanical or you are choosing electrical or automation, it is very important that you take the general one with the one that you actually was specifying, and that's the one that has to do with industrial maintenance safety. So that's for everyone. In industrial maintenance safety is for everyone, and then you can now choose any other one that you want to specify. You can choose that, but try as much as possible to do what you can afford. And the good thing is that we have actually given, like a fast track discount that is time band on this. The value of each of these certification as specified is 40,000 naira, and trust me, when the discount day is over, after the 40p after this 60%, you're going to have 40% discount, and that will be all. After the 40%, it goes to the normal price. You can also go on our YouTube. Most of these recorded videos, share it out to people to benefit from. It doesn't mean that this training has ended. The recorded videos can still be used to train yourself and even those people that miss this training. So all you just need to do is to keep yourself magnet, like a magnet, to our channel, because once you take the certification, everyone who will get our certificates will be added to our channel, where you can always get information, share informations. I just checked now. I saw somebody posting a question on the WhatsApp platform. It doesn't mean that you have to wait for the trainer. If you know how best to contribute to that question, you can also do as well, because it's a word of a connection for professionals. So you may be facing a challenge, one challenge or the other at your place of work. Maybe you are working on a machine or you are performing a maintenance. You can quickly share the question there for people to contribute. As the trainer can also contribute. Moderator also is very, very versed in this field. He's just doing the work of moderating in this particular course, so he can also contribute. Everyone can contribute. So let's build a word of safety. Let's build a word of proper maintenance, longevity for all the machines that we are using, maximized efficiency for all the machines, and also safety for the operators and also for our environment. Thank you very much for your participation. Subscribe to our YouTube channel, as the moderator has rightly said, and do your best in attempt all the assessments. I wouldn't tell you to say, oh, I want to take only one certificate, let me attempt this. Just test out yourself. Let's see what you've got from this training. Thank you so much. Over to you, Mr. Moderator.
All right, thank you very much, Mr. James Fanny. Yes, so on that note, we are going to be drawing the curtains here on this 3-day long class. All right, okay, so thank you very much, everyone. We are going to be communicating via the WhatsApp platform. So please, let's do well to relate there. Yes, if you have the organizations, you need trainings that you want us to come maybe train your staff members. Yes, we are very much open. Our website is open, so you can go to our website to see the courses that we offer, or you reach out to any of our administrators on any of our WhatsApp platforms. So we are very, very much open for business. So we'd love to connect with you. Okay, so thank you very much, everyone. On that note, we are going to be signing out here. So it's great having you all on board. So till the next time we are going to be seeing, please do have a productive day and week ahead. Goodbye, everyone.
Bye, everyone. Bye.